So this is the second half of lesson 9.4. We're going to talk some more about inverse matrices, and we're actually going to go through how to find them. So we've already talked about the identity matrix. We've talked about how to tell if matrices are inverses. Remember that if we multiply A times B and B times A, we get that identity matrix. We also know how to tell if a matrix has an inverse. Remember, if the determinant is 0, there's no inverse. Otherwise, it does have an inverse. So today we're going to focus on this last one of how to find the inverse of a matrix. We're going to be doing a lot of different stuff with inverses. So we need to know how to find them both by hand and with our calculator. So please make sure you have your graphing calculator handy. I know quite a few if you checked them out, and you can just hang on to them until I return. So for a 2 by 2 matrix, we start by finding the determinant. Remember, part of it is if the inverse or if the matrix has an inverse, the determinant will not be 0. So it's always a good idea just to check the determinant anyways, to make sure you're not trying to find an inverse of a matrix that has no inverse. Once you find the determinant, you go back to your original matrix, switch A and D, and change the signs of B and C. Once you do that, you multiply by 1 over the determinant. So that new matrix, after you switch the stuff, multiply by 1 over the determinant, and this is your inverse. You can always check your answer simply by multiplying your inverse and your original and see if you get the identity matrix. So let's work through this a little bit. Okay, we're going to start by finding the determinant of A. First of all, this is going to tell us if the matrix has an inverse, and then we're going to use it in our process. Remember, we multiply 3 times 5 is 15, minus 8 times 2 is 16, which is negative 1. So I'm going to multiply 1 over negative 1 times the matrix of, I'm going to switch A and D. So this becomes 5, this becomes 3. And I'm going to change the signs of B and C. And now I'm going to multiply this by 1 over negative 1, which is negative 1, which means that my inverse matrix is, I should probably write that correctly, shouldn't I? Negative 5, positive 8, positive 2, negative 3. Now we should be able to multiply this by the original and get the identity matrix. So real quick, let's just check it by multiplying and make sure that we, and by we I mean I, did this correctly. Okay, so I'm going to start by multiplying the first row by the first column, and I get negative 15 plus 16 is 1. And then the first row by the second column, I get 24 minus 24 is 0. Second row by the first column is negative 10 plus 10 is 0. And then second row, second column is 16 minus 15 is 1. So I do, in fact, get the identity matrix. So I know that I have found my inverse, okay? So again, let's use the correct inverse notation. So the inverse of A, or A to the negative 1, which is the correct way to write it, is negative 5, 8 to negative 3. I would expect that a 2 by 2 you can definitely find the inverse of by hand because it's not terribly difficult, okay? Once we get into some of the larger ones and once we're solving, we'll use our calculators, but I do expect that you know how to do this by hand. So again, let's start out by finding the determinant of B, which is 24 minus 2, which is 22. So I'm going to multiply 1 over 22 by my changed matrix, and that's going to be the inverse of B. So remember, I'm going to switch A and D, and I'm going to change the signs of B and C. And now I'm going to multiply by 1 over 22, which gives me 4 over 22, which is 2 over 11, and negative 1 over 22, and negative 1 over 11, and 3 over 22, which is, again, the inverse of B. Now, if I multiply the two of these, I should get the identity matrix. I'm going to go ahead and let you check that. Let me know if I did my work incorrectly, but I think we should be good. Let's try one more. This would probably be a good point. Pause the video. Try this one on your own. See how you do. Again, try it by hand. See how you do, and then restart the video and check it, okay? I'm going to start by finding the determinant, which is -8 minus -20, which is 12. I'm going to multiply 1/12 times the 8 and -1, -5, and +4. And that's going to be the inverse of C. So I'm going to have 8/12, which is 2/3, -5/12, 4/12, which is 1/3, and -1/12. Okay, and again, we should be able to multiply that out and get the identity matrix. And we do. Now, a 3 by 3 is definitely something that we want to use our graphing calculators for, okay? So make sure you have it handy. We're going to do kind of the same steps, and then we're going to talk about how to find the inverse. So first thing you want to do is enter the matrix, just like we've been doing. That's in the Edit menu. Quit. So remember how to quit. You push second, and then the mode button, and that takes you back to your home screen. Go into the matrix menu and select the matrix you want, and then you're going to push that X -1 button. And what you'll see on your calculator be this. And then you can push enter and your calculator will tell you what the inverse is. So again, let's try this. So grab your graphing calculator and go ahead and enter this matrix. This is a 3 by 3. And so you want to enter it all in. Make sure that you're putting the right numbers in. That is important. Always double check. And then hit second and mode to quit. So you should be back to your home screen. Go ahead and choose matrix A and then hit that X -1. So you should see on your screen A -1 and hit enter. You can see that your inverse matrix is 12, -7, 3, -20, 12, -5, 1.5, -1, and 0.5. Now, a lot of times we're going to want to keep our answers in fractions because they're going to be more exact. We're going to get, like, for example, when I was doing the one that was 2/11, your calculator is going to give you kind of an ugly decimal for that, and it's going to be rounded. We always want to be exact. So to change these to fractions, simply hit, once you have this matrix on your screen, hit the math button and enter twice. So you should see on your screen, I'll write this out. You should see this there, hit enter, and it converts this 1.5 into 3/2 and the 0.5 into 1/2. So it'll change those decimals into fractions for you. As a general rule, I'm okay with the 0.5s, but that's really about it as far as decimals go. I want you to be writing your answers in fraction form because it's more exact, okay? And we're going to get some funky fractions or some funky decimals, so the fractions are more exact and will not have that round off error. Let's try another one. Go ahead and enter this matrix. Again, remember, it doesn't matter if you enter it as A or B. I've named it B, but it doesn't really matter. You can call it whatever you want to. Once you've entered the matrix, again, quit, and then on your screen, um, choose your matrix and hit that X -1 button, and you should get a new matrix that is the inverse. This one has quite a few fractions, so I'm just going to convert it right away. Again, they're not terribly ugly ones, but we just kind of want to get in the habit of using fractions in our answers, okay? Fractions are always more exact, and a lot of times, especially if we had to multiply this by hand or try to do something else where we were plugging this in somewhere, number one, we always want to be exact, but number two, fractions are a little bit easier to deal with that way, okay? So here is your inverse matrix. Go ahead and check that out and make sure that you've got that correct. Try C here. Go ahead and enter this into your matrix menu and find the inverse of it and see what you get. This might be a good time for you to pause the video and to enter it all in and see where you're at, okay? So this is one that gives you those really ugly decimals that I was talking about. So you definitely want to convert this one to a fraction because it's one of them is, negative 10 over 153. We don't want that as a decimal because it's not going to be exact. Let me write all this out here. Aren't you glad you don't have to do these by hand? Having to deal with these ugly fractions, that would be a huge pain. So here is your inverse matrix. Check all your fractions and make sure that you got those. So again, a 2 by 2, I would expect that you would be doing it by hand. A 3 by 3, I definitely expect you to use your calculator for, okay? Now, we didn't go through and check the determinant on any of these. We probably should have, but they worked out nicely. The reason that we find inverse stuff, though, is so that we can solve an equation, okay? So what I've got here is an equation of matrix A times something equals matrix B. In order to solve that, we take the inverse of the coefficient. So A is called the coefficient matrix because it's the coefficient of the variable. We take the inverse of that and multiply by B. Now, notice this is not B times the inverse of A. Be very, very careful about the order, especially when you're putting this into your calculator. You have to do inverse of A first times B, okay? That's really important because you will not get the right thing if you don't do it in the right order. So we're going to try this. We're going to take the inverse of A times B. Make this one A, make this one B. Now, you are welcome when you're solving to use your calculator for this, especially because there's two of them and you have to find the inverse as well as multiply. So I would very strongly suggest that you use your calculator, okay? So enter in A. And then enter in matrix B. And then quit, okay, to go to your home screen. And this is where you're going to go to the matrix menu and choose A, and then hit x negative 1 times, and then choose matrix B, and hit enter, and you should get this matrix. Okay, so your answer is a matrix here, and we find it by taking the inverse of the coefficient matrix times the answer matrix, or B, okay? Again, order is really, really important. You have to make sure that you are putting them in the right order. I always like to label them A and B so that I know. Or if you always do them in order, that kind of helps too, okay? So same thing again. We're going to take the inverse of A times B. So go ahead and enter your matrices into the calculator. And then make sure that you quit, okay? If you don't hit quit and you go and try to enter it, it's going to put a matrix inside a matrix, and it's going to get kind of ugly really fast. It's going to cause some mess for you, okay? And then make sure you're taking the inverse of A times B, and you should get your answer matrix, which in this case is 6, 12 and a half, negative 4, and negative 9. Which means that if you multiply A times this answer matrix, you should get B, okay? You can always check yourself that way just by multiplying to see if you get the answer. That's absolutely a great way to check, okay? This also works for non-square matrices, and this is why that order is so important. Because if you try to do a 2 by 3 times a 2 by 2, you're going to get an error. But if you do a 2 by 2 times a 2 by 3, you're going to be fine. Once again, go ahead and enter your matrices. Remember that B is a 2 by 3, okay? It's not a 3 by 2. Make sure you get the dimensions right on that one. And then always remember to quit, and you're going to take the inverse of A times B. And you should get an answer matrix of 18, 19, 10, -3, -4, -2. And there's your answer matrix. So again, we can solve matrix equations. This is eventually going to get us, we're going to talk in the coming lessons about solving a system using matrices, and it's kind of cool how it works. But please remember, inverse of A times B. So you're taking the inverse of the coefficient matrix times your B matrix. Go ahead and try this one. This is a good spot. Pause the video, see how you're doing. Make sure that you know how to enter it. Make sure that you are getting the right answer, and all of those things, okay? And your answer should be something that you're going to need to convert to a fraction because you get those ugly decimals. So we've got 2 13/3 and -4, 7, 40/3, and -10. All right, so go ahead and check that out. Make sure that you remember, choose the math button and hit enter to convert to a fraction. We always want to be as exact as possible. So please make sure that your answers are in fraction form. I would expect to see them like this, and not with the decimals. Now here's another one. This one is a little interesting. We've got a 3 by 3, and we're going to solve for x, and get a 3 by 1. So again, the order is very important. Make sure that your first one is A, your second one is B. Go ahead and enter this and see what you get. This is where dimensions are really important. Make sure that you remember that B is a 3 by 1, meaning that there's 3 rows and 1 column. Sometimes that's hard to remember the dimensions. We talked about that at the very, very beginning and how important it was. So please make sure that you're getting the dimensions correct, okay? You should get an answer of 3, 8, -11. And congratulations, you actually just solved a 3-variable system. So if you remember back when we were doing this and we had to eliminate or substitute, and we had to do it twice, and then we had to solve for the remaining variable, and it was this huge process, and your evil teacher made you do it all on paper when you could have just used a matrix and your calculator. So now we know how. And we're going to talk about that more in the upcoming lessons, how to solve systems and different ways to do it. So hopefully you can analyze an inverse and tell if two matrices are inverses or if a matrix has an inverse with the determinant. You can find an inverse. Remember, a 2 by 2 you should be able to do by hand. Anything bigger than that you would need a calculator for. Hopefully you can solve a matrix equation by using the inverse, and then know what the identity matrix is as well, and do all of that stuff with inverses. You do have an assignment posted on Schoology. I'm sorry I don't have a paper copy for you this time, but you can always do it in your notebook and then send me a picture, okay? So please work on, finishing up 9.4. Hopefully I'll be back to see you guys on Friday, and we can start working on some of the applications of matrices and how we use them. If you have any questions, let me know. You can always email me. Otherwise, I'll see you soon.